at the multiplication examples now. It says expand and simplify. So according to our steps, we're supposed to be able to take the numerical coefficients, multiply them together. So 2 times 4 is 8. And then I'm supposed to take what's underneath the root signs together, which is 3 and 6, and that is 18. So that's multiplied together. Now it's not in simplest form, however, because the square root 18 I should recognize as being the same as 9 times 2. So that would be 3 square root 2. Sorry about that. Shouldn't be a 3, should be a 2. Okay, so if you need to reduce something, sometimes it works well if you take it and put it to the side as your rough work so you can do some thinking. So what happens is this 8 is the same, it needs to be multiplied by 3 square root 2. Now normally I wouldn't put this step down. I would just take the 8 and the 3 and multiply them together. So that's 24 square root 2. Okay, second question. Same kind of concept. I do the 5 times the 3, and I end up with 15, and then the 2 times the 10, which is 20. Square root 20 is the same as 4 times 5. 4 is the perfect square, and I'm left with root 5 after in there. So you could write it like this step if you want, so that you are keeping less in your head. So 15 times 2 is 30, so we end up with 30 square root 5. Now, number 3 and actually number 4 are similar in the sense that the roots in both cases are the same roots together. So root 3 times a root 3. Well, root 3 times a root 3 is actually the number 3. The reason being, if I do root 3 times root 3, I'm going to get root 9, which is 3. And it always will turn out that way. So for instance, number 4 is root 5 and root 5. So I know when I multiply root 5s together, what I'm really having there is just the number 5, because it would be root 25, which is a perfect square, which would be 5. And so we'll finish that question up. Okay, the next question now, starting with distributive law, actually really what we're doing here. So we have 2 square root 3, and it's being multiplied by a bracket. And inside the bracket, we have 2 radical terms. So again, the same kind of concept. This comes in here, 2 times, and there's a 1 here, so it's 2 square root. 3 times 15 is 45. Then we do the 2 times square root 12, so we have 2 square root 36. Okay, so now again, I need to put them in lowest mixed form. So if I look at square root 45, square root 45 is the same as 9 times 5, so that would be 3 root 5. So I have 2 here, I have 3 root 5. And if I look at the next one, the square root of 36, perfect square, people, it's 6. So just finishing up, 2 times the 3 is going to be 6, square root 5 minus 12. And the last question, you can see that we have a binomials. So it means that we can use FOIL, so this times this. So we have 2 times the square root of 2, so we have actually 2. Square root 2 times square root 2 is going to be, it's like number 4 and 3, it's going to be 2. And then we have 2 times the 5, so we have a positive 10 square root 2. And now we do the inside part, so we have negative 5 times square root 2, that's going to be a negative 5 root 2. And negative 5 times a positive 5 is negative 25. So again, now I go and I collect like radicals. So everything is fine so far. So we have here 4. These go together, a positive 10 root 2 minus 5 root 2. So we have a positive 5 root 2 minus 25. Put everything together. I'm going to put the numbers first. We have negative 21 plus 5 square root 2. So the work, there's a fair amount of work with this section 1.4. So as I said, it might take you a couple days in class to get all the work done. But I'm sure you'll have so much mathematical pleasure.